Good morning. Welcome to you all. Welcome to this Edinburgh Chamber event on the value of data to your business webinar, which is offered in collaboration with CodeClan. Some of you will know me. I'm Alexia Haramis and I head up the corporate and international development at the Chamber. Before I introduce our speaker today, just a little bit of housekeeping. This event will run for up to 1 hour with some time for questions, which my colleague Rebecca will manage. Please post these on the chat function or do raise your hand. And if you could please just remain on mute during the presentation, that would be appreciated. Just to let you know that we'll also be recording this session. So we live in a world where new technology plays an increasing important role across the economy and society, and businesses need to continually update their workers' skills in order to remain competitive. And individuals need to keep up to date with the changing digital landscape. In order for Scotland to have a world-leading digital economy which supports business needs and promotes technological innovation, it's crucial that everyone has this digital skills. Digital skills are key to improving productivity, especially in those most excluded parts of the country, often outside urban centres, and are an essential ingredient to help the government and industry deliver the industrial strategy. If we can crack the system to help raise levels of digital skills across the country, this will be a great step in driving up opportunities and production throughout Scotland. There is no silver bullet for this, and it will need collaboration across Scotland, the government, industry, and the voluntary sector. And as many of you will know, data-driven innovation is a major part of the Edinburgh and South East Scotland City Regional Deal. The University of Edinburgh and Heriot-Watt University are leading in recognition of the region's strengths in technology and data science, and the growing importance of the data economy for everyone, and the need to tackle the digital skills gap. I think my connection's going. I hope you guys can still hear me. We're pleased to be partnering with CodeClan on this event. CodeClan's mission is to bridge the digital skills gap and develop a new generation of digital professionals and upskill the workforce to enhance Scotland's growth. CodeClan was founded as a not-for-profit organisation in 2015 by Skills Development Scotland and Scotland IS, as a key part of the Scottish Government's digital strategy for Scotland. Based on successful coding bootcamp models in Silicon Valley, New York and London, CodeClan developed an immersive course accessible to people from non-tech backgrounds and closely aligned to Scottish industry needs. As Scotland's National Digital Skills Academy, CodeClan will answer a number of questions, uncovering the true value of data for your business. We are lucky to be joined today by Stephanie Boyle.
Oh, did you want me to speak? I was
It just says it's gone. I thought I'd lost my internet then. It was like internet connection lost. So really happy to have you with us, Stephanie, today. I'll give you a quick intro about you. Steph comes from an academic background, achieving a PhD in cognitive neuroscience while teaching data analysis at the University of Glasgow. She's transitioned into industry, where she worked in the pharmaceutical industry as a lead data analyst. Steve is now a senior data instructor at CodeClan, where she teaches on boot camps aimed at helping people retrain and often start their career in tech. So thank you, Steph, for joining us.
No problem. That was nice intro, thanks. I think she's frozen. So.
Are you frozen? Yeah, there's problems with internet. Mine keeps going down. I can see that.
Yeah, we couldn't hear anything you were saying. I don't know.
Oh no, could you not, Rebecca? Oh, what a shame. Do you want me to start again, or you guys okay? Do you want me to
hand over pieces of it? So I think what we'll do is we'll just start with Stephanie in her presentation, and then we'll move to the Q&A, and if anyone has any questions, then we can circle back to them.
Yeah, perfect. Thanks, Steph.
Yeah, no worries. Right, so I'm going to share my screen. Make this big. You'll have to excuse me. I've been teaching all day, every day for weeks, and I pretty much lost my voice by this point. So I don't smoke 20 a day or anything. I'm just working hard. So yeah, thanks for having me. Well, I mean, I got sent a brief from our events team about what you wanted to talk about. So I've tried to take bits from a course that we do run that maybe answer some of it. We don't have time to answer like all of things about value for data in half an hour. But we've got some like topic points, and I've got a case study to talk about that sort of encapsulates all the stuff we think is useful. This is like, it's not like we're used to doing coding boot camps. So if you have a question, please just ask. Like, it's not formal, like just interrupt me. It's more appealing when we have interaction. It's nice to see people with their cameras on as well. We tend to say, please switch your camera on as well if you can. Makes it more fun for us. So please just stop me if you have any questions. It's more of a discussion than a lecture. So I didn't realize there would be an introduction about me already, so I put this slide in, but everyone knows me already. I guess I'll just say in case the internet was cutting out for people. Yeah, I work at CodeClan. I work on the data course. I write the courses. I teach them. I teach all our short courses. I've been there for about 2 years now. I started as a freelancer at CodeClan while I was working as a data analyst in the pharmaceutical industry. And then before that, I was doing a PhD in freelance stuff and teaching. So I've worked in data for a while. Usually we'd go around and ask people about their intro, but we'll skip that because this is more of a sort of talk, I suppose. But that's me, so you can ask me any questions. I sort of tried to summarize the brief document I got sent into 3 things, because I think that's all we really probably have time for. And what we're going to say is, like, what we try and learn is, how does data science add value to an organization? Why is it worth investing time and money into it? And, you know, what's the context? Like, what are the teams you need, goals and limitations? So we'll talk a little bit about that. A sort of caveat before we start, I suppose, is that we know that not everyone has data science teams. We know that a lot of people doing data analysis, especially in small companies, are not trained analysts. Like, for example, CodeClan, we don't have analysts. We've got people that do data stuff as part of their job, but, you know, it's not the actual data analyst. So when we talk about the context, you know, I am aware that not everyone has a data science team. So I'll try and be mindful of that as well. Cool. So the first half is the sort of value of data bit. And then I'll talk about the roles as well after. So why collect and use data? So we put this stuff on. It's not the be all and end all, of course, but it's what we think are the most common ones. So the first one we're going to talk about is improved operations. And for that, we mean things like not so much automating your business. You can do that, and a lot of places would do that. That's what they'd use for. But just to improve like the general efficiency of it. If you've got data that you're collecting about even just like staffing levels, just using that data to see where your pinch points are would be an improved operation. There's no point collecting data and making a graph and doing nothing with it. Data is only useful if there's an actionable item, you know, and I know that a lot of people know this, but I think that's the key point. A lot of things in places I've worked as well, places I've freelanced for, have huge, vast amounts of data, but almost all of it's entirely pointless because it wouldn't help their business in any way. It's just collecting data for the sake of it. So the first one is like acting on it, and that would be the operations. Improving decisions. So I think people always associate if you do data analysis, you're going to have better decisions, and that's not true. You can, you know, data analysis will just tell you things. You still have to make the decision. You have to decide what questions you want to ask, and you have to be the one that makes the call, says, okay, yeah, we're going to do that. So improved decisions is a funny word. I think it guides decisions to be more logical. Because certainly I've been in situations where, you know, one person comes to me and says, oh, I went to a party and 10 people said that they would really like this product or something. I'm like, oh, okay, cool. And then 10 minutes later, someone else is like, well, I went to this different place and 10 people said that they wanted this complete opposite thing. And because it's not in one place, it's all anecdotal. Essentially, I'm just like, oh, it's just cancelled each other out. You've both given me nothing because you've just got into your own little echo chambers of people who like want what you want. You know, you have to put out a survey and like include everything. Say, you know, do you want this, 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 or this? You know, and get a full picture. So improve decisions if used carefully is what I'll add. Identify blind spots is a good one, and it's one that I don't think a lot of people sometimes associate with data. Because there's this big idea and I suppose buzzword about how data can improve decisions, but actually it's more useful sometimes to see like big gaping holes in your business. You know, if you plot something over time, it's very easy to see where things increase or decrease, and actually sometimes it's the decrease that you need to look at, like, you know, where are the months that we're the weakest or we don't make the most money, or you know, what departments we've got too many staff in, what departments we've got too few staff, can we split that? Like that kind of idea is really useful. Improve communication. That one we're sort of referring to, if you've got a business and you can all get on the same page with what's happening, that will be very useful. So for example, if you have like an all staff meeting and you present a graph, a good graph, I'll say, because there's a lot of terrible graphs out there. It brings everyone into the same page, right? And it's kind of going back to that idea what I talked about, like the position, you know, that I hold sometimes is that I'm gathering data from different people and they cannot see that theirs is completely cancelling each other out because they've not looked at each other's. Do you know what I mean? So when it's all in one place, you can actually put it together and be like, actually, there's no difference because everything's just cancelling. And that idea about all of you talking on the same sort of level is really what's key. Because if you've got a good data analyst, they'll be able to do that. They won't sit and preach stats at people, but they will sit and say, well, you need to think about this, this, and this. So that's one. And then the final one that we put in is increase profits. Like for me, I'm not like a business person. I'm just sort of at my core would be fine living in the woods, you know, but like for a business, that is important. And it's not so much about growth. Like I know a lot of times businesses want to grow, but actually you can increase profits just by doing things more efficiently without having to grow. You know, there's no reason to like always aim so big. You can actually make a new market share for yourself and actually downsize the company if you use data well. Does anyone have any questions or comments about that? No? Okay.
Hello. Yeah. Hi. Sorry, I couldn't get myself off mute quick enough. Really interesting what you're saying about increasing profits as well. And one of the things I always think about when we're collecting and using data, though, is also equally increasing our risk, because of the more data we hold, the more value that has. I know you're probably going to come on to it, but how does that kind of align with, you know, the balance of increased risk with all of these great positives that you've just listed for us?
Yeah, I mean, see, to be fair, like I volunteer at a thing called the Scottish Analytical Exchange as a freelancer, and that's for like charities that can't afford to hire data people. And one of the biggest things, and my colleague Aileen as well, she's on the board of a charity, all the charities come to us and say, I don't want to touch it because if I get a GDPR fine, like that is me finished. And actually it's very easy just not to violate data laws. Like you just have to keep it secure. Don't be sending it over email. Don't be sending stuff like unsecurely. And most of the time you're fine. Like if you just have one person that's in charge of it, it's usually okay. It's quite hard to actually violate it. But yeah, I think unless you're like the Facebooks and Googles and Amazons of the world, you're not going to be selling off data to people to make money. And that's really where the bad things happen, because people don't like that, even though it happens all the time. You just need to be careful, I think. We don't really talk too much about ethics in this particular course. We do have a course we talk about that, but yeah, I mean, to be fair, there's a lot of unethical stuff going on with people's data that's totally legal. So like, it's a hard one. I think just being careful. I think the main one that I see is people sending Excel sheets over emails. Like that is actually not allowed if it's got people's details in it. And when people send it to me, I'm like, hey, stop sending me these things, you know.
So I guess what you're saying, if the policies are right and the procedures are right and the policies are enforced in the right way, and it's about awareness, really, it will minimize that risk.
Yeah, 100%. I mean, my old place, like pharmaceuticals, that was, you can imagine how strictly controlled that was, because that's like people's like health data. And I think they had like a lawyer do a 2-hour training session with us, and it was basically like you signed it and then that was you sort of covered legally. And yeah, it was all just about being careful, really, which I think most people are. So, because if you just sort of think, I wouldn't want mine to be done like this way, like that's usually a good gauge, right? So yeah, I think it's hard, but you do need to have someone aware of it at least. It's a good question though. Any more questions? Okay, cool. So I've got this case study which I think sort of encapsulates all of the stuff that we just talked about on that slide. Now, full disclosure, this is my pal works at a place. It's nothing to do with wind farms, but I can't say what it is because obviously that's not allowed. So I've changed it to be wind farms, but it is an actual company based in a city in Scotland. And this is a true story, and they did reframe their business and make a lot more money. So yeah, we'll go with wind farms. So this company made wind farms or windmills, and their USP used to be that they would provide them cheaper, they would come out and maintain them whenever you wanted, and they'd fix them quicker because they had a lot of engineers. That was their selling point. But as time went on, more companies were in this sort of market, and it wasn't really doing anything. Like, they weren't like a dying company by any means, but they weren't making any money more than what they did. They were comfortable. What they decided to do was like pour a huge front end investment in, and what they were going to do is they were going to install sensors on all of their products, the windmills, and they were going to hire a team of really qualified data scientists and data engineers. And what their new thing was going to be was they were going to hike up the price and say, you know, what is the value to your business if I can predict when this is going to break, and I will fix it for you before it breaks. So you'll never lose a day where you've planned like a big thing, an event or something, and everything breaks and you suddenly have no power. You know, that is very costly. And so that's their new like unique selling point, is you'll never have an equipment that breaks because I can collect data from the sensors and I will send an engineer out a week before because I can tell when it's going to break. And they did that, and they've just completely massively overtaken it because people value that more. They sort of say, okay, yeah, I'll pay a bit more knowing that I will never have it break. That's what people want. And now they're the biggest wind farm person. And, you know, that was like, I think that's a good example of exactly what it is, because they didn't necessarily go and hire loads of people. They weren't interested in growth as such. They just wanted to like figure out a different entry point almost, and then the growth happened naturally, and it was just using data really carefully. But obviously it required a huge investment up front, and that is, in my experience, a very tough sell to get people higher up to listen to, that you need like more staff or more money or something. It's like you can't have growth without putting a lot of stuff into it. So, you know, I'm sort of saying that as a successful one, but given what I've heard behind the scenes, it was like a very well supported decision from the business leaders. So there's that to consider. Does anyone have any questions or comments about that one? Cool. I think it just kind of encapsulates everything we talked about. What I wanted to talk about it with regards to that case study and the other stuff as well is like what data can't do, because I think people see data as this holy grail, and you hear a lot of people say we're a data-driven organization, And then, you know, their analysts just sort of are like with that little meme with the side eyes, like, no, we're not, you know, like, because there's, you know, it's not enough to just have data. Like, that doesn't mean anything. You need to think about what it actually cannot do in terms of what it can do for you. So, like, data cannot make decisions for you. It can certainly guide you, but you have to have someone making that decision, right? In the case study, you know, they're collecting huge volumes of data from those sensors, but it can't actually say if it's broken, right? It needs someone to sit down, program something, write a model that's going to say, you know, when it gets to this temperature, we know from past experience that that's something about to break. So we have to tell someone to go and do something. You know, data can't actually automatically decide a lot of stuff for you. You need people in place to do it. And the same, like, taking responsibility for those decisions as well, right? Like, if that wind farm thing hadn't worked out, they would have bankrupted the entire company, essentially. But that's why you need leaders, because that's what they're for. That's why they are paid the most money, is to take responsibility for all the stuff that's affecting people, right? Like, the people on the ground doing the work are not the ones that usually have, like, you know, the decision-making power. We can give you data and say, this is what you need to make a decision about. So that's quite important to remember. Because I think a lot of people think that if they just collect data and, like, fling it off to someone, it's going to do something magical, and it won't. The second one is take into account the wider implications. And so, for example, in that first example about the wind farms, what actually happened there was, so they obviously had this initial investment in the technology and the technical people. And what happened was the windmills were never breaking. So then they had a huge workforce of engineers that had been there for 20, 30 years that were not technical people, apart from they could fix the product. And they were sitting there with nothing to do. And what happened in that company, and fair play to them, what they said was, right, we're not going to make redundancies. What we're going to do is we're going to bring in some of the engineers into the data team, and we are going to work with them to build models to say, like, right, if you went out to a windmill, what was it you would check to see if it was going to break? And a lot of this time, the engineers were like, well, I would kind of just look at this bit and see what was happening. And you can't really collect data on, like, someone's intuition and looking. So then they started building devices to, like, adapt the stuff that was in there so it could send data. And then eventually what happened was, because they started supplying more people, they didn't hire, and this is what I was talking about, is that you don't necessarily need to grow your company to be more profitable. They ended up having more sites to service, so they didn't have to let go any of their existing workforce. They didn't really hire any new people as such, but they didn't have to make redundancies. But that is because, like, people up top thought carefully about, this has an impact on people's lives if we have to let people go. And they brought them into the data team, which not all companies would do. So I think that was a really good idea. You do need to think about that. Anything you automate is going to get rid of someone's job, essentially. And then the third bit is figuring out how to pick what questions you need to ask or how to address what you find. So it's very different collecting data, but if no one has a question, it's really rough. There's definitely a common misconception that if you hire a data scientist, they're going to come and tell you what to do with your data. That's just not what our jobs is. It is to be given data and questions that are business, like, applicable to the business, and we translate them into data questions and then find the answers to those. You know, someone coming into your business, if you think about it just from a logical point of time, if you hire someone new, they don't know what your business is. Like, how can they possibly figure out what questions are important to your business until they've been there for a while, you know? So really, you have to have good questions in mind, and then the data can be analysed to answer those questions. And then thinking as well, asking the questions before you collect the data is really useful. So, like, I was just talking about, like, that anecdotal example where people come and say, oh, I heard this, let's do this. And then these people come and I heard this, let's do this. And the two of them are completely different and they don't make sense. If you go out to collect data being like, and I'll just use an example from, like, an imaginary example from CodeClan, because that's what I know right now. So imagine I said, I think we should do a Python course. Can someone go and collect data and see if people want to do a Python course? on the surface that sounds fine, but actually it's the completely wrong, biased way to collect data. Because if I go out and put a survey out and say, who wants a Python course, how many days, what do you want to pay, I'm only going to get people answering that want Python. You know, like nobody is going to give me any other opinion because I've only asked for one opinion. Like that is the wrong way to do that. What you should do is you should say, oh, I think people want a Python course, but that's just me. I don't know better than everyone else. And then you go and you make a survey and you sort of say, right, I'm going to make a programming course. Would you want it to be R, Python, SQL, SAS, MATLAB, SPSS? You know, put all the options in, because then people will respond and you can get a ranking. You know, you should always try and rank product features instead of have one person's opinion go into data collection, because that doesn't work. It just always will provide biased data. And that's really tough for people to reconcile because a lot of people are like, but I think that. I'm like, well, yes, me too, but it doesn't mean it's right. You know, it's really difficult for people to get out of that headspace, because, you know, the whole reason you collect data and do statistics is to sort of say like, well, some stuff seems like common sense and that will tell you what's not. You know, it's really difficult. So that's kind of the summary. I think the next bit is, oh yeah, we'll talk about that in a second. Has anyone got any questions or comments about any of that?
Again, I find it really interesting. Sorry, I just can't sit and let it. So the idea that you were just saying then is that data is more powerful, or you have a greater power with data in your organization than just proving or disproving a hypothesis. Like we think about going out and finding scientific evidence that supports or disproves something that we think about our business. So the bigger power of data that's perhaps overlooked by businesses is just what you're describing, that, you know, it's something more far reaching than we're used to thinking about. Let's use data to prove or disprove something. Actually, we have the power to use data to find out things we never really knew about our business and the way that it's run.
Yeah, 100%. And I think that's why, and it's, you know, like obviously, like I am a trained data scientist, so it's like a data scientist telling you need data scientists is that kind of like, you know, Obama putting a medal on himself meme. But I think that's where the thing is, because there's a lot of people, and there's nothing against it. There's a lot of people doing a lot of data work in like HR departments or like stuff like that because they have to, but they haven't been trained in statistics. And when you do statistics, just like you say, if you're trained in the scientific method, you know that most of the stuff you'll find in a data set is something you'd have no idea about. You know, there's exploratory analysis and predictive analysis and descriptive analysis, and it's all very different. And yeah, like sometimes when I'm just like plotting stuff, I see stuff and I'm like, oh, I would never have thought that, like just by like thinking about it, because a lot of the time, I mean, like one example I can think of, for example, is at CodeClan we started doing remote cohorts and in-person ones when the pandemic started, and you know it was nice. I like doing the remote ones because it's more inclusive. You know, like anyone in Scotland can come rather than just being in Edinburgh. And I think there was this idea that the remote cohorts weren't as full as the in-person ones just because there's so many and we had 3 campuses. But actually, when you plotted the data last year, what you saw is, you know, all the remote ones were hitting their targets higher than the in-person ones. And that kind of went against what at the time people thought, because we've always been an on-campus teaching thing. So that was like, oh, okay. And I remember actually our CEO looking at the plot going, oh, that surprises me a little bit. But it was good business info, you know. And obviously you have to then take that with a pinch of salt. It was like, well, we're in a pandemic. People didn't want to come into class and wear masks 10 hours a day, you know, like, so maybe that's why the remote ones were fuller, you know. But there's always this, like, you start, you find something, you go away, you'd have to collect more data, you find more stuff, you know, it's like this cycle process. And other things as well that I've seen, because you mentioned scientific method, and it's maybe worth mentioning, like, what you see a lot of times on graphs, if I just draw like a terrible bar graph like this, I see businesses a lot of the time showing a bar graph like this, and maybe this is like 2019 and this is 2020 and this is 2021, and it's like average scores or something. And I've yet a lot of the time to see them put like something called error bars on them, which any data analyst would put on a bar graph for you statistically. because what it means is if you put error bars, and I'm not going to get into what an error bar is because that's stats lesson, you might have something like this, and just a really simple addition of an error bar would tell you statistically there's absolutely no difference between any of those values. So if it was like profit margins or like survey feedback or something, even just as simple as like getting someone to do that gives you more info than you think. Because a lot of people are used to seeing like a bigger bar and thinking it means something, and most of the time it actually doesn't. But you can make bad decisions based on like that false assumption that if a bar is higher, it means something, you know. So there's all these like really simple ways, I think, that can add stuff. It doesn't need to be, nothing needs to be machine learning. Like I can write machine learning algorithms, but I think they've maybe used like 1% of the time. Like 99% of the time, a business just needs like a good analyst making bar plots, you know. So yeah, no, cool. Anyone else got any comments or questions about that? What time is it? Yeah, I'm just looking at time. I think this kind of sums up what I just said on that slide anyway. You know, it's not guaranteed it'll be a successful decision just because it's based on data. Data can obviously be wrong as well, or it can be biased. I think people remember the Amazon scandal where they tried to do that recruitment thing, that recruitment algorithm that was like rejecting women's CVs. And that was actually right. That was right based on the data. But the problem was Amazon just for the last 20 years just didn't really hire women. So what actually happened was it was rejecting people if they had like, I think in America, there's like women-specific colleges more than there is in the UK. And what it was doing was Amazon had never hired anyone from those colleges. So if you had that on your CV, it was like, nah, Amazon doesn't hire people like you, you know. So the algorithm was right, but it was the decision that was wrong, right? Because they didn't check it. Same with the SQA stuff that happened with people's grades, right? There's nothing wrong with the algorithm. That's it, like it did exactly what they asked it to do. The problem was that the data was biased, and then people made a decision just to go with it because they fundamentally misunderstood what coding does. You know, there's a big uproar about the algorithm, and I was like, I highly doubt some poor like junior dev in the government is responsible for this SQA scandal. You know, like they're just literally using data that they're given, and they're being told to do something. So that's a bit above their pay grade, I would think. So yeah, so you can like misinterpret it. And then like, again, the analysis can be mistaken as truth, which isn't always true. Most of the time it is, but it's just always good to be aware that there's bias everywhere in data. People that analyze the data are biased, the data itself is biased, people that collect it are biased, you know, like you just have to really be careful. Any questions about that?
Not a question, but just a comment on your point about outcome of analysis being mistakenly treated as the truth. It happens in business a lot, and just a recent example I came across was in leadership capability and leadership traits, where basically it's come about because there are sort of assumptions about what makes a good leader, but those are based on past leaders and their successes, and there have been more men in leadership positions in the past than women. Yeah. And the traits are different. So the traits which are found to be the ones are held to be the ones which are successful in one half of the population, not that traits that are not so commonly found in the other half of the population, who can be equally successful but will do it potentially in a different way. So I think your point about you need to sort of examine where the data's come from and question the data rather than just blindly accepting it as the truth is really important.
Yeah, definitely. Yeah, that's such an interesting example because I have a degree in psychology as well, and a lot of data is actually really related to psychology because you have to collect data carefully, right? Especially when you're dealing with humans. So in that example, yeah, they've gone and collected a biased sample, right? Like they sample people that were leaders. Now, they might just be men, and there's a whole host of reasons, right? Like, because women have to have kids, and then they're stuck at home, or they don't get the same opportunities. You know, and the better way to do that would be to actually probably go to the lower level managers, who are mostly women, you find in companies, because especially in tech companies, the guys don't want to touch management. They're not interested. So, like, genuinely, in my experience, the management falls to women, especially in the sort of tech bro culture that tech is. And actually what you should do is go and ask all their employees what they think about their manager, not ask the manager what they think about themselves, you know, because that is biased data. And that's what I mean, like, if you've got this sort of background in like survey design, it's quite, you know, obvious, as you say, to like not do that. But then people do it, especially with, I mean, like, psychology as well is rife with bad data. I know that as a psychologist, like, a lot of it's been disproved and stuff anyway. So it's like a double-edged sword there. But yeah,
no, definitely. Because you see it in a lot of employee surveys as well, and you know, and you think, well, these are the top things we need to focus on, and these are the things we're really good at, and these are the things we're really bad at. And if you look at the company overall, that might be the case. But unless you actually look within the groups that have reported, then it's not necessarily the same thing, which is an issue for everybody. So making a decision about we need to improve teamwork, or we need to improve collaboration, or we need managers to be more this or that. It's not necessarily actually that the whole company needs that, but potentially groups within the company that need it. Anyway, interesting. Thank you.
That's such a good point as well, and that's again bad survey design. I think, like, we had the same thing. Like, I keep using CodeClan because I work there, obviously, where like last year there was like loads of staff surveys because they care and it's a nice company and they want to make things better. But what they sort of didn't do was split it up by department. So it sort of came back like, well, people are feeling a bit like disconnected, so we're going to have like walk and talk, like Zoom calls at lunch in the park. Of course, for the office staff, that they wanted that. Delivery team were sitting there like, are you serious? I spend 8 hours on Zoom every day. I'm not switching to a tiny screen on my lunch break to talk to people in the park. Like, my eyes are bleeding. I need to stop, you know? So, and it was just that idea that one group of people had no issue because we had social contact too much, you know, but then it was so important for the people that didn't have that nice, like, constant contact every day. I would have really struggled if I didn't have that. So I totally see where they're coming from. But then it led to this, oh, the delivery team are not doing this. I'm like, I can't, like, please, I cannot go. I don't want more technology, you know. I will come in and sit in a park and talk to you face to face somewhere, but I'm not doing a tiny screen. So it's such a good point that you just need to sort of think carefully about what you're doing as well, because it will lead to stuff with nice intentions, because they're very well intentioned. CodeClan's a wonderful place to work, but it was just a bit, you know, it's like, let's not do that for everyone.
Yep.
Nice. Cool, right. I'm going to crack on because I look at the time, but it's fine because we're having a conversation during it as well. We'll talk quickly about the roles in data. Now, this is going to be like an overview. And again, I said, I appreciate that not everyone has a data team. I'm sort of talking about, like, if you're a business and you want to get serious about using, like, data, you might think about hiring someone that's trained in statistics and analysis and survey design and stuff. So before I begin, I just want to say, like, there's no universal definition of a data analyst, data scientist, new one, data engineer that every company agrees on. They are very, very different positions in their true sense of the word. But I looked online, like on LinkedIn for our students to try and help them. And I've honestly, the amount of names for the same job was unbelievable. So there's just many job titles. So if you're actually thinking about hiring one of these people, it's good to know the difference, I suppose, but not limit yourself as well. So if you went to somewhere that was, like, actually using data, like, core in it part of its business, for example, when I was in pharmaceuticals, this was very necessary because that was his whole business. You'd have this core data team, and that would be a data engineer, a data analyst, and a data scientist. Now, these are very different roles. The people looking for each of these will be very different. For example, I would not click on a data engineering job ad because I just would not be qualified for that. Like me, I have a PhD in data science. I wouldn't be qualified for that. And I saw someone say, one of my recruiter friends, he was like, why are people not applying for this? I'm like, because you call it a data engineer. It's like if it's not a data engineer job, don't advertise it that way, and then you'll get different people. So these are the 3 core roles. Now, deliberately being a bit misleading and not telling you, because I want to see what people think. What do people think are the difference between these roles? Does anyone want to take a guess, or does anyone know as well?
I'll take a stab, but I'm absolutely unqualified for this. So I'm going to go for data analysis is when data's, so it's sort of like post data collection. So they're the ones that kind of break it down and understand what the information actually means. I would say the data engineer is probably the person at the start. So like before the data is collected, to kind of work out how it all gets put together. So they're the people that try and work out like the bias and type thing. And then the data scientist, I would maybe say, is the kind of person in the middle stage of the data collection, who is kind of helping to facilitate the data collection and the actual practical element of that.
Okay.
That's what my guess is.
Nice. Has anyone got stuff they want to add? Does anyone think any different? It'd be cool to start like a flame war right in the middle of this.
I feel like data scientist seems more technical.
Okay.
And it's maybe more there's more scientific method employed, and I feel like engineer is someone who, and I think if someone was to engineer data, that it would be, I don't want to use the word manipulate negatively, but it would be engineered in certain ways to support or present something. I don't know. I think that at the core they're all pretty similar, right? They're pretty much, I don't know. That's my stab in the dark as well. I'll see you, Rebecca. I'll raise you something else that I don't know about.
I like it. Because this sort of, because I have this so much from people who likes it, are asking what the difference is, and I'm like, oh yeah. And it is like a minefield actually if you're not trained in it. So has anyone else got anything to add before we talk about them?
Is the data engineer relating to more the structural side, if you can actually talk about structure within data, but sorry, any more like where the data gets stored, how it gets retrieved, cleaning and all that kind of stuff?
Yeah, cool. Anyone else? I'm deliberately not giving away the answer yet. Does anyone else have something? Okay, well, all the things were there. Some of them were like a little bit different. So data analyst, and I like to think of the data analyst as like the core workhorse of the data world. And I feel bad because it gets such a bad rep because it's not seen as like data science got pegged as like the sexiest job of the It's just a statistician with a different name. But data analysts are like what most people need. Like I know the government has like 400 analysts, like it's really what people need for business. So they would take data sets, they would find like questions, they would do statistics on them, they can build dashboards, they make graphs, they can make reports. They're really this like middle ground between the back end of building databases. I wouldn't know how to build a database at all, but I could definitely take data from it and give you some useful reports and dashboards. They're the sort of workhorse of it. And I think as well, most people need data analysts, but they don't want to hire for it because it doesn't sound fancy, is really what, in my last 2-3 years experience, is found. Data engineers, someone talks about this. They're responsible for the back end. So actually data engineers are mostly software developers. If you've done like a data science degree, it wouldn't qualify you to be a data engineer at all. Because what they are responsible to is for building databases, for migrating them, storing them, making sure they're secure. If someone needs something moved, that would be a data engineer. Like for example, a lot of the software students at CodeClan go on to be data engineers. The data students can only do that if they've got a background in IT and infrastructure. Like that's how it works. And it's like sort of moving away from IT systems into data, because you have these big cloud systems and computing servers and you need to maintain them and keep them. But these people are mostly software developers, which is why, for example, I would never click on a data engineering job because I just wouldn't fit it. And then data scientists are actually like the sort of someone said it as well, like the technical side. So in their true form, they're supposed to be the ones, they're usually like PhD level trained. Their main job would be to build like predictive models, classifications, write stuff that can go into production, things that are going to like automate stuff. Like it's very maths heavy, very statistic heavy, and very, very technical. But saying that, I've seen job ads for data scientists that are like, must know Excel. I'm like, you know, like, because loads of the students, for example, wouldn't apply for that because it says data scientist, but actually they'd be way more qualified to do it than they think. So that, you know, people call it data scientist, but you don't need it. I was in a course last week and someone said the main difference is like 40 grand in salary, which maybe is also true. But I don't actually think it's that different now. Like, I think all of these are roughly hovering around the same. The data scientists, maybe because they're usually got PhDs, are going to demand more, not demand more money, but because there's more demand for them, because they're more technical, it's usually a bit higher salary. Has anyone got any questions about that? There's only like a couple more slides to go in and I'll be done. I think this is a really important one because people always get them confused, and it does limit your workforce if you're hiring for them. I put up this slide and I can send the slides on. I think Becca's got the slides if you want them, because I put out a post on LinkedIn, and loads of my, like I have quite a big network now because I've been in data for like 10 years. They all have senior positions places, and I said, what was it you would hire for? And this is kind of what they came back with. Now, I'm not going to read through them, but what you'll see is like most of it is not super technical. You know, there is obviously programming experience. That is a necessary thing if you want to be a data analyst. But a lot of it is just like curiosity, learning, data literacy, thinking, problem solving. So you might already have a lot of people that can do this, and they actually just need a bit of like stats training. You know, there's no reason to hire all these fancy new people if you've got this in-house, which is why I put it on, because I think people think you need to have like huge volumes of like experience to do it, but you don't really. You just need to have like a good attitude. And then the last thing I've sort of said is, if you're going to think about hiring, like think before you do it. And that seems weird, but a lot of people, and in my experience, we've seen this a lot. They hire data scientists because they think they need one. And it's because it sounds trendy to have one. Like one of my pals went to a startup as a data scientist, and then he said he was just a really expensive desk ornament because they had nothing for him to do. They didn't even have a database, and he didn't know how to build a database. He was like, well, you hired me to solve business problems. What are the business problems? And they had no idea. They had no data. Safe to say, he was there for about 2 months, and he was like, I'm off. This is rubbish, you know, like. Because the thing about these technical people is they want to do technical stuff, so they will move on very quickly if you don't have something for them to do. So that's why it's just important to think about which one you're going for. Because in my opinion, most people need an analyst. Yeah. And then yeah, that's me. I finished. Yeah, I've put the CodeClan stuff is on the slides if you want to get in touch, but. Rebecca's got my slides anyway. If you want them, she can forward them to you and stuff. So yeah, that's me. I'll stop sharing my screen.
Fab, thank you, Steph. That really, now I'm just sitting here thinking every single survey I've ever sent out is incredibly biased, and I've put on events and stuff that probably maybe shouldn't have ended up going on because of the data that I collected that was probably totally incorrect. So it's definitely going to make me think differently about the way that we do business. But even just, I think data's given this, like you say, like the holy grail, and it's almost seen as being unreachable and untouchable to just the normal everyday workers. But actually, in a way, all of us are data analysts. So for instance, the marketing team at the Chamber, they're looking at how tweets are, like what data is coming back from tweets. Are they doing well? Are they doing bad? Like the information that's gathered from that. And they're having to analyse that, and actually, could we be gaining more insight and more knowledge from that data that we have if we understand it better, rather than it just kind of being numbers and stuff, and you kind of know what they're talking about, but you don't really. So having that extra knowledge does give your business a lot of opportunity. So having someone that spends their day literally understanding what the data means and can translate it back, because I think that's one of the issues in business at the moment, is that bridge between having the data and actually understanding what it means and what the possibility of the data is. So yeah, I found that really interesting. I'm going to open it up. Does anyone have any comments or questions or anything that they want to maybe ask Steph, or any examples of data use in their business, that is how it's helped to actually benefit them, or anything that they've realised that actually we have all this data and it's sitting there and the possibilities are endless with what we could achieve with it?
Hi, Steph. That was so good and so interesting. The reason I'm here is we have a cybersecurity company, so we're all about, I want to learn more about how I can communicate to people, and especially sort of medium-sized businesses, why their data is valuable and why they should work hard to secure it. So I think what my takeaway from this today is, people are like, there's data there, and it's about harnessing it and using it in the right way that can actually be transformational for your business. Not just can we understand things better, can we understand our customer better, but you exemplified with the wind farm. That to me was like, that's data driven innovation. They're innovating the new technologies to change the way that they do business and future proofing their business, and all of that was based on data that they were collecting, or data that they could harness in the right ways to really empower their business. So for me, thanks for like sharing all of those things, because it's great for me to be able to communicate that to our prospective clients and say, data is not just what you collect about your clients or your customers. It's so much more than that, and it has real value within your business. And then my other comment that you were saying about people not knowing what a data analyst or engineer or whatever is. Chandler in Friends was a data analyst for years, and notoriously not even his closest friends ever knew what he did for a living. So I don't think we've moved on in 25 years.
That's so funny. I'm going to use that because nobody knows what I do, so that's quite good. No, that's great. No, that's good. I'm really glad you got something out of it. So.
I also actually have a friend, and she used to work in hospitality. And then when COVID struck, she obviously was put on furlough and she had a lot of spare time. So she decided to try, it was actually a course with CodeClan. I think it was like a short taster course. And she just thought, yeah, why not? I'll give it a go. And then on the back of that, she decided to do, I think you've got like an intensive course. So she did like a 4-year degree in like 3 months, which literally sounded so intense. And now she's working in data, but I'm the exact same. I don't know which one she is, but she tells me all the time and I don't really understand what it is. So I'm just like, oh, nice, how's that going? But now I'll actually be like, oh, right, okay, so you're the bridge between business and data and stuff. And she'll be fair impressed that I now know all this information.
That's funny. What was her name?
Amy Brown.
Oh, I don't know if it's on her. I don't know. We do so yeah. I mean, I suppose on that point we do loads of short courses. Actually, it's really good right now. You made me think of that because the last 2 days I've been teaching Python to like people in the hospitality industry that've been on furlough for a long time. They got funding. They were like the manager of the garage there, and I was like, oh, 16-year-old Steph is like, this is the dream, like, because I grew up in Glasgow. I thought it was amazing. Yeah, it's amazing what you can learn in a couple of days. We do those 2-day, 3-day coding courses for like data analysis, and you can actually apply. The data lab do credits. You can apply for like £500 to come and learn stuff, which is really good as well. It can make it really free, and just like you said, then people go on and do these different degrees and stuff. It's amazing. So
because she was definitely not a kind of person that you would ever expect to have an interest in data, but she did. So as well as maybe employing someone specifically, bringing someone into the business who is a data analyst, there is also the opportunity to upskill, because it might actually be there's someone sitting in your business that actually would love to have this insight and already understand your business, so has that knowledge there as well that you could invest into upskill to help your business, but also it'll really value them as well as an employee. That upskilling is definitely an issue as well, with obviously with COVID. I know roles in the chamber have all kind of changed and moved about, and everyone's doing something slightly different than what they were doing a year ago, that there might be someone sitting there thinking, you know what, this is the type of thing I'd love to do. So just even checking if in your businesses there is that opportunity for someone to take this role on and upskill them and train them, because there obviously is a massive gap for that skill set, that having that business knowledge already saves a lot of time on the back end when they come out of doing that training, having to kind of be like, okay, this is what our business does, this is what we're looking for. Having someone in the business that understands it already saves a lot of time in that area.
Yeah, definitely.
Does anyone have any other questions or comments before we wrap up this morning? No? Perfect. So thank you so much everyone for coming along. As Steph said, I will send out the slides to you all afterwards so that you have a note of them. If there's anything that we can help with, please do just let myself know. If there's anything more that you want to find out about data and CodeClan, then please do get in contact with Steph. And thank you so much, Steph, for your time this morning and for the presentation. It's really helped to humanise data, I would say. So thank you so much, and we look forward to seeing you at an event soon.